We're going to focus on covalent compounds first. They're a little bit more complicated. There's more to learn, and more compounds are covalent. So we're going to do a little bit more with them. So a covalent compound is made from nonmetals. And of course, covalent means we're sharing electrons between atoms. Covalent bonds are harder to break than ionic bonds, and that's because they are sharing. The electron clouds in there actually do overlap because they have electrons that are literally spending time with each of the atoms. They are non-electrolytes. You know that when you put them in water, they don't split up and form ions, even if they do dissolve. And the attractions between molecules are pretty weak. So let me explain that a little bit. If we have an ionic compound, the attraction between these two ions is pretty strong. Okay, and it's for that reason that when you have an ionic compound, it ends up being a solid because those attractions are pretty strong. Well, these attractions here are really strong. In fact, the covalent bonds are stronger than these bonds. But these, on the covalent compound, those attractions do not make it into a solid. It's the attractions between, so this dashed line, the attractions between molecules. So for covalent compounds, each molecule is pretty solid. And there is a weak attraction between the two. You may know that the weak attractions between the two, maybe you have something called hydrogen bonds. Maybe you've heard of that before. Anyway, in lesson, the materials lesson, we will talk a great deal about these attractive forces, but know that they're pretty weak for covalent compounds. We're going to be drawing how the molecules are put together. We're going to be showing all their valence electrons. And so we use Lewis dot symbols to do that. And for these, you only use valence electrons. So if you look on your periodic table for carbon, you'll see that it's in the column that has 4 valence electrons. And so I have 4 dots there. Oxygen has 6. And so now I'm starting to pair them up like this. It does not matter which sides I put the pairs on. You don't want to put, like 3 on one side. They go in pairs. And you need to kind of watch the geometry that you use to draw them. So you can imagine you have a square, and then the pairs, as you get them, fall on the square, those 8 positions. If you end up having one that has more than 8, we'll say you just kind of added at an angle, but these are kind of our 8 standard positions. Okay, let's look at the formation of a covalent bond. So if we look at chlorine, each chlorine has 7 valence electrons, you can see from your periodic table. And the way you can see this is that these two right here, if they would kind of come together, they would make a pair, which would give them both 8. And that's what happens here. So when that happens, these two electrons are being shared. They are a bond. And if we count, we would count them for each chlorine. So if I want to count this chlorine's electrons, I'm going to count all 8 there in that circle. And same thing with this chlorine. I will count all 8. Those 2 in the middle count for both. So both chlorines have their octet. That makes them more stable. This is another way of drawing the same thing. This dash represents a bond. So the dash represents a single bond, and that is 2 shared electrons. It's this pair right there is our shared electrons. Shared electrons are always in pairs, and this is called a single bond. This one's a single bond. Because it has 1 pair. When they have 2 pairs, you can have a double bond, and if it's a double bond, you'll have 2 dashes. But anyway, we'll see that a little bit later. Okay, when we start drawing these dot structures, you need to know some of the terminology that we'll use. One of them is the types of pairs as far as bonding and lone pairs. So when I, oops, let's go back to that. I guess I have to draw that in. So when I say a bonding pair, I'm talking about this. This is a bonding pair. And lone pairs are these on the outside. So lone pairs kind of are to the outside, bonding pair there. Okay. Bond order, just some more terminology. Bond order is the number of shared pairs, and we were just kind of saying this. Here's a structure. This is the same molecule drawn two different ways, showing its shared pair there is the same thing as this dash. So in this case, I have, for this bond, I have one pair of electrons. So I would say this is a bond order of 1. Or I will say it's a single bond like we just did. Okay, this one right here, this is a double. Bond order 2. 2 shared pairs, so there are 4 electrons being shared there. This one, those are a lot of electrons. That's a triple bond. So 3 shared pairs. Okay, and some simple trends with bond order, and these are pretty intuitive. Bond order, again, is the number of pairs. So if we have a double bond, the bond order is 2. Okay, bond strength. Which do you think is stronger? This is a bond order of 1 versus a bond order of 2. Which is stronger? Of course, what you would think, the stronger bond is going to be the 2, the one with the bond order 2, or I guess I could say that one. Okay. Bond length. This one is not as obvious. Bond length is the distance between nuclei. In other words, if I have the 2 carbon atoms and I have their nuclei, I'll just make that a nuclei. What's the distance between those? That's a measure of bond length. And so how far apart are they? And what it ends up is that the more electrons they're sharing, the closer they're going to be pulled together. And so that's what it says. A distance is shorter for higher bond order. So in other words, triple would be the shortest, then double, and then single are the longest. So which one is shorter here? Would be the double. Okay, so these are the instructions for writing a Lewis dot structure of a compound. And I put these in here for you to kind of refer to as we do some examples, but a few things I want to fill in. So you're going to start by writing a general skeleton, and it tells you how to get the general arrangement of the atoms. And we'll look at that. You have to determine how many valence electrons. You look on the periodic table to get the number of valence electrons. If you happen to be drawing the dot structure of a polyatomic ion, for an anion, are those positive or negative? These are negative and these are positive. So if you have a negative ion, you're going to take the number of valence electrons that it would normally have with all of those, and you're going to add electrons because it has extra. If it's a cation, you're going to count up the electrons that those atoms would normally have and then subtract electrons according to the charge. And then the order that you distribute when you start putting the dots on there is very important. Pay attention that when you start putting the electrons on your atom, you're always going to start with the outside atoms and make sure they have their octets. And after you have all the outside atoms or surrounding atoms, oh, and by the way, on this structure, this is what I mean by the outside atoms. Sometimes we call those the surrounding. and we call the one in the middle the central. So we're going to always put the electrons on these outside ones first, and then if we have more, we'll put them on the center. So central. Okay. Okay, sometimes you'll have to adjust the electrons once you get them all on there, and we'll see you basically will move them to make a double bond if your central atom doesn't have enough. And of course a polyatomic ion, you're going to put brackets in a charge. Okay, so we're ready to look at some examples now.